Hello again. Tonight we're going to talk about off-world outposts. Think of it as we're going to set up encampments off Earth, Moon, Mars, Venus, Mercury, Enceladus, which is the moon of Saturn, those kind of places. There are different classes or forms of encampments. There's habitation, which is smaller, shorter duration, cycles periodically, cruise and such. Think of it like the International Space Station, which is highly dependent upon resupply communications with Earth. There are outposts, which is what we're going to focus on. Those are longer duration, yet they're still dependent upon stuff from the home world, meaning Earth. There's expectations of periodic resupply, replacement parts, staff rotations, and then there's actual colonies or colonization. That's where you attempt to break away as much as possible from Earth's dependencies. You find ways to produce your own air, water, food, energy. You might be mining local materials for source materials for doing things. So you might be, let's say, mining silicates that you can then use in a centered laser kind of 3D printer to melt the particles together to make objects. And if there's metals in them, then you can have metal things that you can make from local materials. So you wouldn't be using 3D plastics like PLA and such. And you wouldn't have the ability to set up a large metal foundry that could melt raw ores and make extruded materials from metals. That would just be a lot of stuff to set up. If you have enough people around in your colony, you might want to think about establishing what laws do we follow? What's good versus bad? And then to handle when things go bad, you need an enforcement system, and you need somebody to say, yep, they were not doing right. So you need judgment, you need courts, and then some way of penalizing them. You're obviously not going to ban them to the surface where they'll die from vacuum or heat or radiation or such, but people are doing wrong. You've got to do something. And then you might even attempt population expansion, which means you probably have to build more structures. So your structures are likely built from local materials. But that's all quite a bit complicated, and we're way out over our skis if we're talking about colonization. So we're just going to talk about outposts, which need periodic resupply and get parts from Earth and rotate staff. The pictures that you might see of humans on other places are all over the place as to what the facilities look like. And you might have rovers and solar panels, or if there is an atmosphere and it has wind, you might have wind turbines that aren't being blown by air, they're being blown by methane or something, but different until they actually do one different. So I'm going to say this presentation is predictive and a bit presumptive. And what it's saying is it's predictive in that I'm going to point out some things that people might want to pay attention to if they want to have successful outposts, not colonization, just outposts. And presumptive in that I'm not career trained or experienced in these sorts of efforts, but I have worked with some large scale systems and been able to spot things and correct large scale deployments and such. So, and also I know how to analyze and see things that are analogous or similar efforts, like the McMurdo station in Antarctica, what it is, how much it has, how it relies, and then other things that might not have been quite as successful, like Biosphere 2 in Arizona. Antarctica's McMurdo station is long-standing, and McMurdo is just the U.S. aspect of it. There are other long-term stations that are in the Antarctic, so it's multinational. And all these outposts, not colonies, but outposts, require resupply. They're not freestanding. They need a home planet to get stuff from. They may do research or mining or fabrication of their own things, but not large-scale production. Hopefully, these sort of closed environments are not purpose for psychoanalytical research, which is kind of one of the aspects of what happened with Biosphere, that when you put too many people into a controlled environment and you don't allow them to get out, even though the outside would be enjoyable, you keep them inside, people can have problems. So let's go through the readily recognizable stuff. Let's presume that you're off Earth, you're in an atmosphere that, if there's an atmosphere that's present, it may not have an atmosphere, but it's unbreathable. The atmospheric pressure is incompatible. It could be too low, like Moon or Mars, or the pressure could be too high, like Venus. You're going to need some kind of containment and source gases, and maintain the appropriate pressures to keep people living. You're going to need a acceptable temperature range, an acceptable day-night cycle. You can't have 5 years of night and then 1 day of daylight. That wouldn't work with people. Is it too hot or too cold? You're going to need systems that will adjust that to make it acceptable. What about the gravity? Now, the moon has 1/6 gravity of Earth, so not zero, but the International Space Station has microgravity. Not quite zero, but simulates zero. So anything from about 0 to around 1 g that's okay. If you get above 1 g as a constant, if it's a low, like 1.2 g or something, it's probably tolerable. But when you get to greater than 1 g, like 2 or 3 g's constantly, that presents all kinds of issues for circulatory systems and such. If where you're going does not have a sufficiently dense atmosphere, you need a defense system from micrometeoroids, cosmic rays, solar radiation. You need defensive measures. If you have no local food sources because there's not a viable atmosphere, you not only have to bring your own, but if you're going to grow any, you have to grow it indoors because you can't grow it outdoors. I was looking at some lichen, basically green fungus, in Japanese gardens up in Delray Beach, Florida. And there was a lot of them on the rocks up there. And I said, I wonder how well they would do in low pressure, low temperature environments because they're going to get lots of solar radiation. But that's probably something they need to look into. It's highly likely that there's not going to be any convenient local water sources. The water's not going to be sitting there in a lake if the atmospheric pressure is so low that the water evaporates. Even if there's water there, it might not be immediately usable. It might contain toxic materials that have to be filtered out. And if you have a large enough quantity of people there, you might need a lot of water on a regular basis. You have to adjust the temperature. You can't drink near freezing water. You have to warm it up. You can't take near boiling water and drink it. You have to cool it down. And once you've prepared the water to make it potable, as they call it, you might have to have a big place to store it in so that you can get at it later, should it be seasonal. Electrical power, you have to provide your own power. Batteries may not be sufficient if you have a long duration of cycle. Solar's okay for some sites, but if you're beneath an oppressive atmosphere like Venus or Titan, then you're probably going to be underground, which means you're not going to be doing solar. And if you're on Enceladus, you may find that to protect yourself from the radiation, you might actually want to have an underwater habitat. So you have to think about that when you're deciding, we'll just put up some solar panels. You may need a small modular fission reactor, not fusion, fission. A full-size fission reactor would be too heavy. You might start off with some radioisotope thermoelectric generators, or RTGs, maybe a couple of them to scale up your power. That way, if you have one of them have a problem, you'll still limp along on less power until you can get replacements. And not fusion, because if you've seen the size of the fusion experiments that they've run, these are very large, very expensive. It would be impractical to transport one, and certainly very much too complex to build one at a distant site. And then you've got to think of communications with Earth. How often can you communicate with Earth? Well, luckily, if you're on the near side of the moon, it always faces the Earth, but the receiving station and transmitting station on Earth is on a rotating ball, Earth. So you may have to have a network on Earth that allows you to communicate with something out in space, because the Earth is rotating, Mars is rotating. They're not always facing the same direction at the same time. And they both have roughly a 24-hour day, so they can get out of sync. And then let's say you need some automation. You've built up enough equipment that you need some kind of AI to run all the, manage all the systems. You may need some data center capability to process all that information. And then if you want to get back from there to Earth, and when you fly to there, you don't bring enough fuel to take you back, you may need to make your own fuel and oxidizer for the return trip. And that usually means if you can find some water, you break it apart into hydrogen and oxygen, and then you get enough of that to have liquid hydrogen and liquid oxygen, and that makes good rocket fuel. So first thing we need to decide is, where are we going to go? If all we want to do is get some experience on how to do this, test out some technology, our ingenuity should we have problems. How about the moon? It's only a few days away, presuming you can get a rocket ready to launch in a hurry. It's a good stepping off point. It allows you to prove out lots of capabilities and what to do in case of a problem, because you're not that far away. And you can certainly radio back on a regular basis. Mars is farther away. It may take a small number of years, 1.5 to 2.5 years to get there, depending upon the positions of Earth and Mars in the orbit around the sun. And then the launch vehicle, if you want to get out to Saturn's moon Enceladus, depending upon how you get there, if you don't want a launch rocket that will squish humans like grapes, it might take 10 years with a slower rocket to get there. And then if you need something, you got to plan for another launch. It might be another 10 years away. The inner solar system, it sounds weird, but you're on Earth, which has a certain orbital velocity around the sun. You have to reverse course and bleed off some of that energy in order to get to a orbit closer in on the inner solar system in order to visit Venus or Mercury. That's the reason why we don't go there that often with probes, is you have to have a fairly powerful rocket to counter the Earth's orbit around the sun to get to a lower orbit. Venus has a very harsh environment, and Mercury is pretty much bathed by the sun. So they're going to be challenges. So let's go for an outpost first on the moon. And then if we're doing great, then we'll try for Mars. So down at the bottom there, you have the moon, Mars, and Enceladus. Sizes are not accurate, but they're approximate relative to each other. Okay, you've decided, hey, we're going to go to the moon. Where on the moon? Obviously, you'd like it to be on the side that can communicate with Earth, as opposed to the far side, not the dark side, the far side. You're going to need some fresh water. Do you want to pull it from glaciers that might be in craters that haven't seen the sunlight for millions of years? Do you want to scrape the surface and get permafrost? Do you want to dig deep to find aquifers? Otherwise, you're going to have to bring all of your own water, fuel, and air, which is what they're currently planning on doing, is bringing it all. And if they get lucky and find some, then they'll try some research to do it. If you do find a source of surface water, like you dig down and you find a glacier or permafrost, is it seasonal? Is it going to be there long term? Does it have salts or minerals or toxins in the water that have to be purified? And then you have to have some way to hold all the purified potable water. If you're going to find it down in an aquifer, it requires drilling. How many feet down is it? Even if you could drill down to it and find it, what's the level of contamination? You don't know. Okay, let's say you're going to use a place on the surface and solar radiation. The solar radiation needs to be rapid repeating, good duration, no long-term period in shadow. What that means is a good daylight to nighttime repeatability, a day-night kind of scenario. Think about it this way. If you're on a fixed location on the moon rotates on its axis such that the same side faces the Earth. But as the Earth-Moon system goes around the sun does basically illuminate the opposite side, but not all the time. So you have to take into account how many days are you going to be in darkness versus how many days you're going to be in daylight. And solar radiation may not be sufficient. You might want to take a radioisotope thermoelectric generator or a modular reactor with you. If you're on the surface, you're going to be exposed to solar radiation, cosmic radiation, micrometeoroids, potentially meteors, asteroids. So you're going to need to build your habitat out of something that's durable enough to defend against that. So if it's just radiation, you might have to have an outer shell that defends against the radiation, and then an inner shell that will defend against things hitting you. And you might need that outer shell to be replaced as the micrometeoroids may eat it up over time. But if you're on the surface, it's easier to launch and land, drop off materials. And if you're building it on the surface, you've got daylight a lot of the time, so easier to assemble things. If you're going to do it, if you're going to make your outpost below the surface, that's another option. On a place like Saturn's Enceladus, due to the high surface radiation from Saturn's essentially electromagnetic belts, particle radiation, probably better to go under the surface, even if it's underwater, to get away from the radiation. It would be beneath the surface is a natural shield. You don't have to worry so much about radiation. Your buildings can be simpler. The structures can be lighter weight, needing less repair on a regular basis. But you still need to be able to land and launch from the surface, maybe get some solar power, certainly have a dish antenna to communicate with the Earth. But if you're going to be building something, you need to understand, does this place have quakes? I'd call them earthquakes, but those are for Earth. So you call them Mars quakes or Enceladus quakes. Does it have ground tremors? What's the frequency of them? How often do they occur? How big are they? Are they destructive? What's the stability of your structures? The surface is something that might be moving. I know that in Antarctica, they have two different categories of habitats. They have the kinds that are bolted down into rock so that even if there's snow and ice, they don't move. And then they have the other kind that they jack them up on legs and they can actually have them move with the ice flow. You could build inside of a cave, but you need to know in advance what the cave is like. So you probably have to send a rover in there. How far in does it go? It may look like it's a cave from Earth, but when you get down there, you find it's only 10 feet deep. Caves have side openings, the side opening into the cave. You need a place that has a front door and a back door in case something goes wrong. A cave, you would have to explore it to know if there's another exit. Another approach is lava tubes. A lot of these places have had natural flowing molten rock, and they make tubes that when the lava leaves, it makes a giant underground tube with a very hard shelled roof, but not so hard that some of it hasn't crumpled in. A lava tube is likely to be large in diameter, long, been there a long time, presumably stable, and where it's fallen in, where it's too thin, you probably have multiple overhead openings that will allow you to get in and out. So if your spacecraft can only go straight up and straight down, that would be a problem. But if it can hover, if it can land horizontally, then maybe a lava tube's not so bad. I would say it's probably a combination. You probably have some systems that have to be on the surface, like communications, maybe a nuclear reactor, your launch and landing pads, but then your habitation may actually be subsurface to make it easier to build and more durable and less radiation concern. And learning from prior efforts. At the bottom, there's two pictures. The one at the top is McMurdo Station in Antarctica. The one at the bottom is Biosphere 2. They're both within the Earth's atmosphere. The difference being McMurdo, when it's the summertime down there, you can actually go outside in a parka. If you're in Biosphere 2, you're locked in there for kind of a contractual period of time to prove out that you can survive solely based upon what's in there without calling back to Earth and asking for something. Notice the difference between the structures. Biosphere 2 is essentially habitation, building stuff. McMurdo is almost light industrial. You see giant tanks that contain things like gasoline and diesel and oils for keeping all the machinery up, and then lots of the individual little buildings. They don't build a lot of big buildings. They build them small because if something happens to them, ice and snow gets heavy and a roof caves in, you didn't lose the entire habitat. And they have one big building. You see the big long blue one towards the back. That's kind of an auditorium. But there are places where you need to work on machinery, and the sort of light orange, pinkish one up towards the top center, that's kind of a workshop. McMurdo's been there over 50 years, and they're now starting to say, the weather's kind of taken its toll on a lot of these structures. Maybe we should build a new McMurdo slightly somewhere else. If you look off to the left, that's the harbor that the ships come in order to deliver supplies to McMurdo. In the foreground, you can't see it in the picture, there's actually a runway. Planes can only come in when the weather is good. Ships can only arrive and depart when the weather is good. So there are months during the year when McMurdo is essentially socked in, and there are actually underground tunnels from some buildings to other buildings, but not all of them. What about the timing? Let's say you have a severe injury, a rock falls on somebody, or they come down with a terminal illness, a virus or cancer or something like that, and they need assistance. How long will it take to get assistance or to take them back to Earth? The possibility of casualties goes up the farther you get away. Even in Antarctica, they've had problems where somebody needed something and they can drop something off by airdrop. But if you needed people down there, like emergency medical services or special physicians, they may not come in time. In the case of things that are off Earth, you have alignment and transit times. The moon is tidally locked with Earth if your outpost is on the near side. If you have a launch vehicle, it's only a few days away. If you're going to Mars, depending upon where things are in their orbits around the sun, it may be as much as 2 years away from Earth. Think about that when you want to get out even further. If you want to build a resupply or emergency launch vessel, if you remember, they wanted to send another SpaceX capsule, Dragon capsule, up to the International Space Station to pick up the astronauts that were left there after the Boeing Starliner was declared not usable for human return. They couldn't just like turn 1-2 overnight. They had to wait until the next scheduled one. And then they just went from, instead of having 4 astronauts on board, they'll have 2 so they can take the other 2 back. If you need a rocket, and it's a rocket that's going to take you out to the outer part of the solar system, it could take years to build it. It could take months to years to verify that it's good, that it's operational. And then you have to wait for weather to be good enough for it to launch. In the case of Mars, Mars has dust storms that are every 2 years that can blot out the entire planet. And even though they're a lower pressure atmosphere, you probably don't want to be launching or landing during a Martian dust storm. And if you miss it due to weather on Earth or weather on your destination planet, you may miss the alignment and have to wait another couple of years. So if you're building a long-term outpost, you may want to include surgical facilities and add in a few medical staff following the first crew arrival. And they actually have a small surgical facility and a small staff of medical professionals at McMurdo in Antarctica, just in case. As far, does science fiction carry this concept of it takes a while for things to get there? Well, yeah, if you've ever seen the movie Outland from 1981 with Sean Connery, they actually had a shuttle docking clock. The only thing that was wrong with it was the place they were coming from shouldn't have been hours away. It should have been days, maybe years away. They were in a moon of Jupiter, and I think it was Io, but that's unrealistic because Io is covered with lava flows. But they had a countdown clock for how soon the shuttle with the bad guy would be arriving. So in summary, at some point in the not too distant future, the concept of humans creating outposts will become highly desirable, just so we can say we can do it. We have the technology. They'll just be expected. It's just the next step in going off the planet. It may be even if they find stuff to mine or research that they can do there, it may have commercial opportunities. I know aboard the International Space Station, they've had commercial fabrication for materials and pharmaceuticals that luckily the ISS was there and it didn't cost much to do that research on board something that your tax dollars are already paying for. If you go off world and you find that, hey, there's a rich vein of gold here or platinum or something else that's even more valuable that we don't have much of here on Earth, like, I don't know, iridium, there may be commercial opportunity there. You're likely to take it international like we did with the International Space Station just to spread the costs and spread the technological effort, maybe add in some commercial if the risk is sufficient. But the investment going off-world is likely to be billions just to get it started, and then billions annually just to sustain the remote outpost. And you need to start thinking about what you're going to do, how this off-world encampment is going to operate, how you're going to get things there, get things back if you're bringing back scientific research results. It's going to take time and lots of resources. And if you get any part of it wrong to the point where lives are lost, it's not going to be publicly tolerable. That's just the way the space programs always worked. But you probably want to think about all the different forms of habitization. Is it going to be short duration, moderate duration? Are we trying to form a colony? Don't get out over your skis. Go for just visiting, occasionally, like vacation visiting. And then if you want something, you can sustain people there Just realize you're going to need supplies. But you can try out all your concepts doing it here on Earth first, as they did for biosphere. And as McMurdo has shown, you need that if you're going to be in the Antarctic all the time. The first place you should try it on off Earth is the moon because it's nearby. It's easiest to get to, and it's the lowest cost to sustain it. But you have a lot of issues you may have to pay attention to, like where to build it on the surface, subsurface, caves, lava tubes, the required resources you're going to need just to exist there. The moon's biggest issues are going to be radiation, impacts, water access. Mars's biggest issues are the transit delay to get there and back, plus all the other stuff you have for the moon. Humans will eventually get out there. They're going to establish outposts. You know it's going to happen. It'll just take time. And then categories of settlements. And there are people already thinking about off-world things. And then if you didn't know about McMurdo, you can find out about McMurdo and Biosphere 2. And there's a organization already talking about a Mars outpost and how you commercialize it. There's a company called Lunar Outpost that is it's already got a rover on the moon that has instruments aboard it that you can pay into to have up there. And they're thinking about putting an outpost up there in the eventual future. And if you want to know more about the moon, Mars, or Enceladus. Comments? Question? Anybody want to sign up for a trip?
I think you guys know my attitude about this. I can see colonizing and working on the moon, but anything else is just too far away. This is my attitude. People do not appreciate how far away these things are.
Well, we recently launched via the Blue Origin New Glenn rocket a probe that's going to go to Mars, but it didn't go to Mars. It went to an elongated beyond the moon orbit of the Earth because Mars wasn't in the right place right now. So it's going to hang out at Lagrange point 2 out beyond the moon until Mars comes whipping around, and then it will change its orbit so that it does a slingshot around the Earth to get enough oomph to make it out to Mars. And it's going to have to wait 2 years to get there.
So was that the original plan, that it would take 2 years, or is it taking 2 extra years?
No, the problem is that Earth and Mars aren't lined up
Yes.
For a most efficient trajectory from Earth to Mars, but about every 2 years. But in this particular case, Blue Origin had a contract that said, you got to prove that you can launch something for the US government. Otherwise, your contract is null and void. So I said, well, what if we go ahead and launch it and it just goes out to L2, but we prove we could launch it, and then it's up to the probe. It's no longer up to our first or second stage. It's up to you bought your own third stage to actually get it from L2 to Mars. So they can claim success of launching a US payload for NASA that's going to make it to Mars, just not soon.
So it's taking longer than the 2 years that they estimated.
Yes,
it would take.
It's basically taking still 2 years to get there, but a year before it can change its orbit to head that way. So total of 3 years.
Yeah. But is that, when we think about the world, like if we think about our planet today, and people are real happy to stay here on Earth, but say in 100 years, the planet isn't as comfortable to live here. Would it seem like that would be such a bad idea to try to go to another planet or another place besides the moon?
I like to think of it as analogous to the historical nature of the human species. People used to come from Europe and get in a covered wagon and head for California.
Right.
It would take them more than a year to get there. And they could die along the way from a number of different things, and a lot did. But they took the risk because they saw something better there than they had where they were.
Yes. That's what I see
too. Better natural resources, and they endured the hardships, but they could still breathe. They could find lakes with water in them. They could catch fish. They could, find nature has an abundance of plant life that they could pick fruits from. They didn't stop long enough to grow anything, So they had to bring stuff along or catch stuff along the way.
But the thing is, that when you get to Mars, there isn't going to be any plants or water or
No,
fishing.
no, there might not even be any potable water. The water that's there may not be pure enough, and we may have to bring along desalinization to make the water potable. But you've got to remember that when you desalinate water, you get ionized water, and that's not drinkable long term as is. It's a common misconception that, well, I just get distilled water. No, you don't want to be drinking distilled water on a regular basis because that will actually leach minerals from your body. What you want is purified water that has a certain number of minerals in it, chlorides, magnesium, the stuff that makes other than distilled water taste good. So if you ever drank distilled water and you went, that tastes terrible, you're not actually tasting the water, you're tasting all the stuff that's already in your mouth. But if you drink filtered water, purified water, those kind of things, that's from a natural source. And all they do is they remove any chlorine or heavy particle materials and they leave all the minerals in it. That's why the place you get these waters from is natural springs.
But going back to what Joe said about going to the moon, there's a reason they're not picking the moon, right? They're picking Mars to go to.
No, there was a lot of promotional stuff about we're going to skip the moon and go to Mars directly. And then they found out, gee, Mars is kind of difficult to get there and harder once you are there. And let's try for the moon first.
So, yeah, but I mean, that's true. They want to see that as like a stopping station, but they want to get to Mars. But I don't understand why they couldn't just stay on the moon. Is it because if our planet is doing so poorly that we have to go live on the moon, that our planet is deteriorating? Well, then the moon would be at risk.
Even worse. The moon would have been worse because at least here for a while, the air is going to be breathable, even if we have to use air conditioning to cool it down.
Well, Mars is not going to be breathable.
Correct. But Mars has a CO2 atmosphere. And part of that, if we can find water, even if it's subsurface, is CO2 has oxygen in it. And if you can find water, you can use electrolysis to split the water into hydrogen and oxygen. So you have breathable air and you have rocket fuel. What you don't have is nitrogen. And if you want to grow anything, you're going to need nitrogen. The thing that you use for fertilizing plants is ammonia, and that's NH3, and that's nitrogen. You need all the pieces of the puzzle if you're going to sustain an outpost without having constant resupply from Earth. And you can do that from Earth to the moon reasonably easily. Not so much to Mars.
But they're thinking that once you get to Mars, if in fact all the pieces come together, they can colonize it. You said they were talking about colonizing it.
It's at this point, it's a fool's errand to think of colonization. Colonization is we're independent. We've got everything we need. We don't need no stinking Earth. That's colonization. An outpost is where you can have a reasonable number of people. You could have 30 or 50 people or something like that living in a colony, but you're still very dependent upon supplies and replacement parts and crew rotations from Earth.
Is anybody thinking of terraforming Mars?
Yes, they are.
That would be nice.
Got $1 trillion?
Yeah.
I got 10 bucks.
Mars is a good portion the size of Earth. And if you want to convert the entire atmosphere, it'll take more than an Arnold Schwarzenegger movie to do it. I don't think the Martians left behind the oxygen generator.
No.
But one of the things that they did mention in a different movie called Red Planet was what the people from Earth did in order to kickstart the conversion is think of photosynthesis. If you can find a rapidly growing photosynthetic plant material that can take in ultraviolet and carbon dioxide and produce oxygen, and it would grow in abundance, you could, over maybe a couple of 100 years, terraform Mars, because you would be basically creating oxygen and also generating water vapor from the plants. What they found out, which when I was growing up and going to high school, we didn't know about, is plants respirate the oxygen they take in the daytime to do photosynthesis. They reverse that pressure at night to balance the chemistry of the plant. So when you think about, look at all the oxygen these plants are generating, and then at night they suck in the oxygen, a good portion of it. The amount that they've produced in a net 24-hour period is not as much as you thought, which means that, hey, we're going to go to Mars and we're going to have a dome, and inside the dome we're going to be growing algae, and we're going to have it under UV lights, and it's going to suck in the UV, and we're going to blow CO2 from the atmosphere on it, and it's going to produce oxygen, and then every evening it'll consume 80% of what it produced. So you're not going to have as much free oxygen as you thought.
Mm.
But we
Well,
might,
you never know. There was an article just the other day that scientists found a mold that was feeding on the radiation from Chernobyl.
yes.
And they were speculating, oh, maybe that could be used in the future to protect the space station and such from radiation to some extent. So who knows what we'll discover.
Even better, they found mold that was growing on the outside of the International Space Station under solar radiation in vacuum.
Wow.
Life
Yeah.
finds a way.
Amazing.
Yes.
And also they have different kinds of photosynthesis. There's C3,
Yeah.
C4, and CAM photosynthesis that
Yeah.
doesn't take in oxygen at night, right? So if we're terraforming a planet, might as well send a plant that maximizes the oxygen production out of oxide rocks, right? Not just from carbon dioxide.
Yes, because Mars is the red planet because of iron rust, which means there's a lot of oxygen there. It's just embedded in the iron rust.
And phosphorus and nitrogen, which I just looked up because you mentioned them, and they're there on the planet as well. So it would seem, they always say it's going to be really hard to terraform it, that it'd be easier to fix Earth than to terraform Mars. But actually, I'm thinking on Mars, on Earth, you can't make it right again by wiping out all of human life and wiping out all living things and reintroducing them. But on Mars, you could do that, right? That you could grow some kind of purple bacteria and then green bacteria and then have the great oxygenation and just plant it all.
Well,
does Mars have enough gravity to retain an atmosphere that would be suitable for us?
Oh, no.
For a brief period of time, yes, you could introduce consumable air and water vapor, and maybe a couple of 100 years later, it would be gone. So you have to continuously produce it. It wouldn't disappear. I mean, initially when you produce it, it will dissipate. But if you produce it at a high enough quantity and you keep growing it, it'll catch the curve and you'll have it for a while. And as long as you sustain it, you might have it for a few hundred years. But eventually the solar radiation is going to catch up with it and it's going to bleed off into space because, yes, Mars does not have a sufficient electromagnetic field to protect it from the solar radiation, and it doesn't have sufficient gravity to hold on to it for a long time unless you put out a lot of pressure.
So what's going to happen to us as our bodies go to this other planet, and we are now subjected to a planet that has less gravity, has less oxygen and water? We're going to adapt. Our bodies will start to try to adapt to it, I would think.
They already do that aboard the International Space Station. Muscles atrophy, bones become porous because there's no gravity that you're constantly fighting against. If you go to the moon and you stay there under 1/6 gravity for an extended period of time, it won't be as bad as being on the ISS for a year, but it will accumulate. And the way that they attempt to mitigate this on the ISS is by having the astronauts exercise resistively for about 2 hours a day. That tends to mitigate it. But if you've ever seen the astronauts coming back from the ISS after they've been up there for more than 6 months, they pull them out of the capsule and they immediately put them into reclining chairs because they don't have the strength to walk under Earth gravity.
And they cut the video so we
Yeah.
don't see that.
I remember it takes them about 6 weeks to get back their full strength.
But is there anything good that our bodies will be able to? Well, I guess that's because we're coming back to Earth that they're
Yeah.
having a problem. If
Well,
they stayed up on the moon
that-
with their bones deteriorating like that, it seems like they would have a problem anyway.
That's
If they were on the moon and they atrophy their muscles and stuff.
that's something to consider. And it may be that after you've been on the moon or on Mars for a few years, you can't come back to Earth anymore. It would be like somebody from Earth going to a planet that has 3 times the gravity. We're not going to be able to easily exist there at all. So it's a matter of gravitational ratios. We haven't done this yet, to anyone's knowledge, but if you're born in a lower gravity environment, will your body even have what it takes to sustain itself in a 1G environment ever? So if you have an offspring on the moon or on Mars, they may never be able to visit Earth.
But you're saying even the parent that had the child, if they stayed up there for 4 years,
Yeah,
they wouldn't be able to
they
come
may
back
not be able to
either.
come back either. Yeah.
So
Have they done experiments with mice or other small creatures to see if their offspring are survivable back on Earth?
Not that we know of, no. But I'm sure that it's something that they've done. Why
Well,
not? What would
sure.
stop them? It's just small critters. They don't care about those.
Devise an experiment to see if you can have sex on the moon.
I did watch the James Bond movie, and there seems to be you can have sex in orbit.
Not the same. Not the same.
Did you see Moonraker?
yeah,
At the end of Moonraker, he's in the cargo bay of the shuttle fooling around.
that's right.
Well, if it was in a movie, it must be true.
Yeah,
Of
there was
course,
an
especially if it's in a James
true.
Bond movie.
Yeah.
Yeah, they did a lot of research for that.
Yeah.
I don't know if people appreciate the extreme danger. There was I think I saw it on Nova the other day. There was an astronaut that was doing a spacewalk to repair something or install a solar panel or something. And he suddenly starts feeling moisture on the back of his head.
Yes.
And it turned out there was a very small leak in his coolant system. And so this water was building up in his helmet. And so he needed to get back in. And there was a whole drama about it. And there was a concern that as he's moving, this water bubble could move around to the front of his face and block his ability to breathe. I mean, it's a simple thing like a tiny leak could kill you.
Yes.
If you're thinking of it on Earth, it's not like you're wearing a glass fishbowl on your head and it fills up from the bottom. And then, once it gets up to your nose, you're doomed. In zero gravity or in microgravity, the water will cling to you.
Yeah.
It won't actually fill up the bubble. It'll just stick to the outside and it forms a blob. And if you turn the wrong way and you give it a little like inertial kick, the blob moves. And if it moved over his nose and mouth, it would suffocate him. But as it did, it actually came down and covered his eyes. So at some point, he had to be assisted to get back into the capsule because the water had covered his eyes and back to the ISS. And yes, it was just a minor water leak inside of his spacesuit.
And there's no AAA out there. There's no calling an ambulance. There's,
No.
But there was, but like what Monroe said earlier, when they had the horse and buggy, they had no AAA either.
Right.
And yet we have AAA today.
Even McMurdo Station in Antarctica, there was a woman that came down with cancer and they diagnosed her there and said she's going to need chemotherapy. And it took a while before the seasonal change such that they could fly in the chemotherapy materials and oncologist to assist her. So yeah, if you're that was just seasonal, so maybe a few months. If you happen to be at Mars, it's a few years. So is there anything else people might have thought of about, well, we didn't think about this particular thing if we're going to be somewhere else?
We may be different types of people by that time. If it's going to take us another 50 years, maybe we'll evolve a little.
Well, that's one of the things that they're kind of thinking about is we could get lucky. And if you're born in an undersea habitat on Enceladus, if you're born in that environment, you may be acclimated to it, to the gravity. I don't know. I don't think you're going to suddenly grow gills because you're not genetically modified to do that. But who knows? We recently genetically modified a material that was injected into someone to cure a disease. We're already playing the game with genetics to see if we can make things from things.
And so far, they didn't find anything positive. I gather you're saying as far as your body changing in space. They didn't, it was all
nothing
negative.
positive. It's all deletory. It's all bone loss, muscle loss, even a certain amount of cognition loss. But
on the other hand, if we spent time on a planet with slightly higher gravity, you could come back and be an Olympic high jumper or a weightlifter.
I like that.
You'd be a lot stronger.
Okay. Do you remember the Kevin Sorbo TV series where he flew in the weird-looking spaceship and kind of like a military defender? He was born on a world that had twice Earth's gravity. So whenever he wanted to do anything on Earth or on the spaceship, he was the most powerful guy in the room because his bone structure, his muscle structure, even though he wasn't like bulked up, he was just higher density, and therefore he could defeat people. Yeah, that could happen.
But is there a planet that we could choose to go to that has?
Not in this solar system, no.
Ah, darn it all. Diane had a great idea.
Yes.
Oh, well.
Venus is roughly the same size as Earth. Jupiter, Saturn, Uranus, and Neptune may be larger than Earth, but they're all gaseous things with small cores. And so there's no environment for us to be in. And even if you went to one of the larger moons, like the largest moon, I think, is Titan. If you went to Titan, it's still smaller than Earth. We have found around other stars beyond the sun in our galaxy what they call super Earths. And the diameter of those planets is about 1.5 to 2 times the size of Earth. And therefore they would have higher gravity than Earth. But I think the number is either 3.5 or 4. When you get to too high a gravity, we don't have any rocket technology that will allow you to leave. We have a formulaic balance of how much propulsion we have to put out, how much we want to launch into orbit, how big the rocket has to be, how much fuel it has to carry, all those kind of things. Luckily on Earth, the periodic table of elements helps us out there because we can launch a Saturn V to the moon. But if you look at the size of the rocket versus the size of the capsule, there's a big difference. Most of the rocket is throwaway just to get you there. So if you wanted to exist on a planet that had twice Earth's gravity, you get an even bigger rocket or a completely new technology not involving propulsion.
Space elevator.
But if I got to the moon, if I got to a planet that has twice the gravity, am I going to be able to even walk around?
You, as you stand now, no.
Yeah.
You might be able to be there for a little while, but it's eventually just going to be so repressive that if your heart lasts, then the next thing will be, can your muscles bulk up enough where you can move around?
Right. Yeah. I don't see that I would be able to go.
It's simple. It's simple to think of it this way. I weigh 175 pounds. If I went to a place that had twice the gravity, I would weigh 250 pounds. I don't think I would be walking around much.
And there are people on this planet that
350. What am I saying?
Yeah, that weigh more than that, and they still can move around. Now, when they get above 500 pounds, yeah, they don't even move around, even on Earth. So divide up the numbers, and yes, you need to start out with a lower body weight in order to exist on a planet that has more gravity, and you have to have strong muscles to begin with, strong muscles and bones.
But even if you're
not
just
a tall person, a shorter person.
I think if you're used to being on Earth and you go to another planet that's double the gravity, no matter what your weight or, if you're an average person, just an average person, and you go to another planet, it's going to be hard to get adjusted to it.
It won't be impossible, but it will be challenging.
Well,
if it's more than 2 times, it's probably a non-starter.
They can scoot around on chairs and stuff. You don't have to have walking,
Yes, yes.
If so heavy,
But
walk-
if you get to a place that has 3.5 to 4 times Earth's gravity,
oh, that's all.
what are you going to use for the propulsion to get back to Earth?
Yeah. Who would want to come back?
Well, yeah.
It would be so nice there. They might have movies. You don't know.
They probably won't have any tall trees. All the trees will be 2 feet tall.
Yeah, well, that was what in Doom, I guess, was the important thing was the tree, right? The tree.
Well,
That's
Well,
what
the
I
trees
got out
might
of
be
that.
tall but very hard wood.
yes, like some of the ones in the desert Southwest that in the 1800s, they actually tried to destroy them because they would get in the way of cattle. Oh, mesquite trees. And now hey, I want some mesquite for my barbecue. How come there's so little mesquite and it's so expensive? Well, because in the 1800s, they were a nuisance to cattle farmers, so we tried to eliminate them.
Interesting how our views change.
Well, you never know what you're going to need until you need it. Okay. Any comments before I stop recording? Hearing nothing.